Hello everyone, and welcome back to BLE Tech Decoded. I'm Andy.
Hi, I'm Mike. Today, we're continuing our deep dive into the ultimate boss of Bluetooth communication, metal shielding.
Before we jump into the core topic, we need to address a comment from our last video. Mr. Molecule Magician had a very creative suggestion. He said, can't you just add an RF relay on the outside and inside, passing through a sealed junction on the container? Why limit yourself to 81 meters?
Haha, Mr. Magician is definitely a pro engineer. You're right. If we could drill holes and install relays or external antennas, the transmission distance would skyrocket. In fact, that would be similar to our open field tests, where we've already reached kilometer-level distances. But here's the catch. Modifying a container is a massive undertaking.
Exactly. There are tens of millions of standard containers worldwide. To achieve truly smart logistics, you can't ask shipping companies to perform surgery on every single container. In Arad Connectivity's test, we want to explore a different scenario: zero modification. If you just toss a Bluetooth tracker inside a thick, sealed steel container, can the signal still punch through to reach a receiver outside?
That's why we arranged a comprehensive zero-modification validation test. Not only did we perform full 6-axis orientation testing for the MN54L series, but we also tested the MN52H U40 series simultaneously to ensure the data is rock solid.
And the data is incredibly comprehensive. The test site was a container terminal, a very brutal environment. We placed the MN54L-C15 at the very end of a 40-foot sealed metal container, the point farthest from the driver's cab, to simulate whether a driver can monitor the cargo from inside the truck.
We set up a duel between two master devices. One was the iPhone 7, simulating a standard smartphone connection, and the other was Arad's industrial-grade MN52H U40, acting as a dedicated Bluetooth receiver.
Let's reveal the results. In that heavy steel box with the signal source hidden in the deepest blind spot, most people would be impressed if any signal got out at all, right?
Right. Our previous data showed the iPhone 7 as a receiver reached an effective distance of about 60 meters. Honestly, for a smartphone, 60 meters through a container is a passing grade. It's enough for a driver to monitor things from the cab.
But, hold on to your seats, using the exact same MN54L-C15 with the exact same orientation, the communication distance shot up from the original 81 meters all the way to over 180 meters.
What? 180 meters? Andy, that's triple the distance of a smartphone. In a total metal-shielded environment, every extra 10 meters is hell mode difficulty. They managed to stretch it to nearly the length of 2 football fields. This means a driver can monitor the container not just from the cab, but even while having lunch at a roadside restaurant.
Exactly. And the most impressive part is that this was achieved with zero packet loss and an extremely stable connection.
But why such a massive jump from the previous 81 meters to 180 meters?
Here is the key variable. The biggest difference between the two tests is the environment. This time, the container was placed alone in an open area.
Oh, I get it. In the previous test, the target container was literally surrounded by metal walls, so it was closely flanked by other containers.
Precisely. In that high-density, surrounded environment, the signal faced extreme shielding and interference, so it reached only 81 meters, and I use only with air quotes there. But by isolating the container this time, removing the metal beasts next to it, both the MN54L and MN52H showcased their ultimate penetration and refraction capabilities.
That makes sense. It shows that Arad's modules have incredible adaptability across different metal densities. Reaching 180 meters in an open area means that even in the harshest terminal yards, you still maintain a massive RF link budget.
So why are the MN54L and MN52H so powerful? It's two core technologies. First, the +8 dBm high transmit power provides the raw radio energy to punch through metal. But the second point is even more critical: superior RX sensitivity.
Right. Arad's 30 years of antenna tuning experience allows their hardware to catch those faint signals that a smartphone would simply discard as background noise. This is the generational gap between professional hardware and consumer electronics.
Now, some developers might ask, Andy, my product isn't for tracking containers. Do I really need this much performance?
That's the concept of RF link budget. If a module can penetrate a shipping container, it can breeze through 3 concrete walls in an office. Even if environmental interference cuts the signal by 90%, Arad's module might stay connected while a competitor's product has already dropped the call.
Exactly. And if the price difference isn't huge, spending a little extra for that margin results in fewer complaints and a better user experience. Choosing the right wireless solution from the start is much cheaper than trying to fix poor quality later with signal boosters.
Well said. This experiment successfully validated the reliability of the MN54L and MN52H in the harshest metal environments. By highlighting the gap between the module and a smartphone, we want to give developers a clear reference. If a phone meets your needs, you can save costs by just using an app. But if you need to push the boundaries, a dedicated receiver unlocks so many more creative applications.
That's all for today. Thank you for watching. Please stay tuned to our show.
If you enjoyed this, don't forget to like, share, subscribe, and hit that notification bell. Bye-bye.
See you next time. Bye-bye.